In this video, we're going to discuss how we measure the distance we think an object traveled. So let's just start with the basic idea. If a car is traveling 70 miles per hour for 3 hours, how far did the car travel? So we have 70 miles per hour times 3 hours. If you'll notice, hours over hours would cancel. And so the result would be 70 times 3 is 210 miles. So our units here are just miles because we're looking at a singular unit, how far the car traveled. So we know speed, or in other words, velocity, times time equals distance traveled. So this is easy because in this case the speed is not changing. We're staying at 70 miles per hour. But let's look at what happens if the speed were to be changing and how we could estimate that. So in this first example, we're going to use what we call a left-hand sum. So we're going to look at this car where from 0 to 10 seconds, the velocity of it's increasing. In other words, at 0 seconds, the car is doing 20 feet per second. And then it speeds up, and at 2 seconds, all of a sudden now it's doing 30, and so on. So hopefully you can see that here. So what we want to do is we're going to divide the 10 seconds the car is traveling into 5 subdivisions. Or we call this n equals 5. It's how many places we're going to split this up into. In other words, we're going to look at how far the distance traveled from 0 to 2 seconds, from 2 to 4, 4 to 6, 6 to 8, and 8 to 10. 1, 2, 3, 4, 5 different subdivisions. And we're going to guess how far the car traveled. So notice, if you split the 10 seconds up into 5 subdivisions, each subdivision is 2 seconds long. We call this delta t, and we'd say it equals 2. So doing a left-hand sum, let's look first at this interval here. From 0 to 2 seconds, we are going to guess that the car during this time is traveling the left-hand number, or 20 feet per second. So guessing how far the car traveled from 0 to 2 seconds, we're going to guess it's traveling 20 feet per second. In other words, 2 times 20 plus. Now we're going to look at from 2 to 4 seconds. From 2 to 4 seconds, we're going to guess that the car is traveling 30 feet per second. In other words, for 2 seconds, we're going to multiply by 30 feet per second. That would be our second interval. Now during the time from 4 to 6 seconds, the left-hand number would be 38. We're going to guess that the car's total distance traveled would be 2 seconds at 38 feet per second. Now from 6 to 8 seconds, so a time period again of 2 seconds, the left-hand number would be 44 seconds. So plus 2 times 44. And then the last interval from 8 to 10 seconds, I'm going to guess the car is traveling 48 feet per second. So for 2 seconds, we're doing 48 feet per second. And so in other words, if I total these up, 40 plus 60 plus 76 plus 88 plus 96. I would guess the car traveled a total distance of 360 feet. We call this, in this case, this is an underestimate. I know it's below the actual value because I'm using these numbers from 0 to 2 seconds during this time span right here. The car is traveling something actually between 20 and 30 feet per second. It's just speeding up. So using the number of 20, that would be on the low end. Well, now let's look at the other type of sum that's going to help us estimate, and this will be a right-hand sum. So splitting these up into the same intervals, we're going to look at from 0 to 2, 2 to 4, 4 to 6, 6 to 8, and 8 to 10. So again, we're going to do 5 subdivisions, and delta t will be 2. But now the difference, from 0 to 2 seconds, I'm going to guess the right-hand speed, that the car is doing 30. So from 0 to 2 seconds, for 2 seconds, we're guessing a speed of 30. From 2 to 4 seconds, the right-hand number would be 38. So plus 2 times 38. From 4 to 6 seconds, I'm going to guess the car is doing 44. So 2 seconds at 44 feet per second. From 6 to 8, I'm going to guess the car is doing 48. So plus 2 times 48. And then from 8 to 10, I'm going to guess the car's speed is 50. So plus 2 seconds at a speed of 50. If we add these up, we get 60 plus 76 plus 88 plus 96 plus 100, and we would estimate the total distance that the car traveled to be 420 feet. Now this would be an overestimate. The reason this is an overestimate is like during this time here from 0 to 2 seconds, the car is traveling somewhere between 20 and 30 feet per second. So using the value of 30 would be an overestimate. But what I now know for sure from the last page is the car must have gone between 360 and 420 feet. Let's look at that example graphically and see what's happening. We're actually going to draw a comparison to area here. And so let's look at what's happening with this left-hand sum graphically. So what I've done with this graph is I've taken our chart, our previous chart that we were using, and I've just graphed the values. So like 0 seconds was 20. That's this point here. And so what we're essentially doing with that math is from 0 to 2 seconds, I'm guessing a speed of 20. Well, if I section that off, I'm saying the area of that red triangle, 2 times 20, is 40. That 40 is the distance that we said the car traveled during that time. From 2 to 4 seconds, during this time, I said the car traveled a speed of 30, doing my left-hand sum. Well, that would be the same thing as the area of this yellow rectangle. It would have an area of 60. From 4 to 6 seconds, doing the left-hand sum, we guessed the speed of the car was 38. And the area of that rectangle would be 76. From 6 to 8 seconds, we guessed the car was doing this speed of 44. The area of that rectangle would be 88. And then from 8 to 10 seconds, let's go back to yellow. From 8 to 10 seconds, we guessed the car was doing the speed of 48. The area of this rectangle would be 96. So what we're saying is the distance traveled is about the area of these rectangles. If you added those rectangles up, that would give us the same value that we had previously estimated. And we estimated that to be 360 feet. And so this is what it looks like graphically. Notice we're trying to essentially model the area that's underneath this curve. What we are showing is that the area under the velocity curve is distance traveled. That's going to be an important idea in section 5.2. Area under the velocity curve tells us distance traveled. If you notice, doing this left-hand sum, my rectangles are below the curve. Because the rectangles are below the curve, that is why this is an underestimate. So a little typo here for this next one. We're now going to look at the right. So cross out left and let's look at the right-hand sum graphically. So if you recall, when we did the right-hand sum from 0 to 2 seconds, during this time we guessed the speed to be 30. Well, if you look, now we're finding the area essentially of this curve, or this rectangle I should say. 2 times 30 is 60. Then from 2 to 4 seconds, we guessed the overspeed, which was 38. If you'll notice, again we get a rectangle that's above the curve, and the area of that rectangle would be 2 times 38 is 76. Continuing on from 4 to 6, we guessed the speed of 44, which again gives you a rectangle above. From 6 to 8, we guessed the speed of 48. And if you look, again, we get a rectangle that's above the curve. This area would be 96. And from 8 to 10, we guessed 50, which again would be a rectangle above the curve. Because these rectangles are above the curve now for our right-hand sum, that's why we get an overestimate. So last idea, when would a left-hand sum be an overestimate and a right-hand sum be an underestimate? It would actually be a case like this, like a graph like this. When the function is decreasing, the left-hand sum will actually be an overestimate. Here's why. If you imagine, if I was to split this up into, let's say, 3 rectangles, and I use the left-hand endpoints, now the result would be rectangles above the curve. Let's look at a similar curve and see what would happen if we did the rights, though. So let's say a similar curve, and now we're going to split this up into right-hand triangles. Well, now my right-hand triangles would not quite fill in the curve, and the result would be an underestimate. So if the function is decreasing, the left hand becomes an over, and the right hand becomes an under.